In this video, we're going to have a look at parallel and perpendicular lines, which is a continuation of the equation of a straight line, which was the video posted on Monday. So parallel and perpendicular lines. So some key formula and theory to note for parallel and perpendicular lines. So for parallel lines, the gradient, which is signified via an m, which we covered in last video's lesson, m is the gradient. For a parallel line, the gradient is the same, and m for a perpendicular line, the gradient is the negative reciprocal, and we write it like this, so negative 1 over m of the gradient of the perpendicular line. So we'll cover that in more detail when we get to perpendicular lines. So this first question says, is the line y equals 3x minus 4 parallel to the line 3y minus 9x equals 21? So if the two lines are parallel, like it says down at the bottom, then the gradient must be the same. In this first line, we've got it in the form y equals mx plus c, but the second line isn't in the form y equals mx plus c. So we need to rearrange the equation of this line to be in the form y equals mx plus c. So we've got 3y subtract 9x, and this is equal to 21. So we need this x to be on the right hand side. So it's negative 9x. So if we add 9x to both sides, we're going to move this 9x to the other side to give us 3y equals 9x plus 21. And then we just want y on its own. This is 3 multiplied by y. So to move this 3 to the other side, we're going to divide both sides by 3. So 9 divided by 3 gives me 3, so 3x. And then 21 divided by 3 gives me 7. So we've got y equals 3x plus 7. And we're comparing this with y equals 3x minus 4. So we've got y equals mx plus c is the equation of a straight line where m is the gradient. So we're going to compare this number here. So 3 in the second equation of a line and 3 in the first equation of a line. So yes, they are parallel as they have the same gradients. Question 2 says, is the line x plus 4y equals 8 perpendicular to the line 3y minus 9x equals 21? So when a line is perpendicular to another line, we need to look at the negative reciprocal. So reciprocal means that we flip the fraction. So if we had a half as a fraction, the reciprocal of a half would be 2 over 1. So that would be 2. So we need to look at the negative reciprocal. So we put a negative sign in front and then flip the fraction. But they need to both be in the form y equals mx plus c first before we compare. So this first line, we've got x plus 4y equals 8. So we're going to put this in the form y equals mx plus c. So we need this x to be on the other side. It's positive x. So if we subtract x from both sides, we're going to get 4y equals negative x plus 8. And then we want y on its own. So if we divide both sides of the equation by 4 to detach the 4 from the 4y, we're going to get negative x over 4 plus 8 divided by 4, which is 2. So this is y equals negative a quarter x plus 2. And for this second line, we've got 3y minus 9x equals 21. So this line is exactly the same as the line in the previous question. So it is y equals 3x minus 4. We rearrange that in the question 1. Now we look to see if the gradients are the negative reciprocals of each other. So the negative reciprocal of 3 would be negative, and then 3 as a fraction is 3 over 1. So the reciprocal would be 1 over 3. And then we look to see if the other line has negative 1 over 3 as a gradient, and it doesn't. So they are not. So no, not perpendicular as the gradients are not negative reciprocals of one another. Let's have a look at question 3. It says find the equation of the line that is parallel to the line below and passes through the points -2, 4. So we've got 4y equals 8x plus 20. So we need to rearrange this equation in the form y equals mx plus c. So 4y equals 8x plus 20. So we just want y on its own. So we're going to divide both sides of the equation by 4 to detach this 4 from the y. So 8x divided by 4 is 2x, and then 20 divided by 4 is 5. So the equation of the line that we're given in the question is y equals 2x plus 5, and we need to find the equation of the line that is parallel to this, and it also passes through the point -2, 4. So if a line is parallel to another line, then the first half is the same because the gradient has to be the same. So y equals 2x plus c will be the equation starting off for this line that is parallel. Now we're given another key piece of information, which is that it passes through the point -2, 4. So we can put this into this equation and solve for c. So this is our x coordinate and this is our y coordinate. So we're going to get 4 equals 2 times -2 plus c. So we're just putting in these points into the formula for wherever we see x and for wherever we see y. So this is 4 equals -4 plus c. 2 times -2 is -4. And then to solve for c, we're going to add 4 to both sides. This gives us c equals 8. So the final answer is y equals 2x plus 8. Question 4 says find the equation of the line that is perpendicular to the line below and passes through the point 5, -4. And the equation of the line that we're given is y equals 3/7x plus 9. So it is in the form y equals mx plus c. So we can say that the line perpendicular to this line will have the negative reciprocal of 3/7. So 3/7. So the negative reciprocal of 3/7, we put a negative sign in front first and then flip the fraction. So we get -7/3 x plus c. Now again, we're given a point, x and y coordinates, so we need to substitute these points into the formula. So our y value is -4, and this is equal to -7/3 multiplied by 5, which is our x coordinate, plus c. So simplifying this sum here, we've got -7/3 multiplied by 5. This gives us -35/3 plus c. So this is -35/3 plus c. It's a negative, so we're going to add -35/3 to both sides to move it to the other side. So c is left alone on the right, and -4 plus 35/3, and this is equal to 23/3. So the final answer is y equals -7/3x plus 23/3. So this concludes the lesson on parallel and perpendicular lines. For more videos like this, remember to drop a like and subscribe to the channel.